Hello, today I will be introducing my final project, my project proposal and design, as well as demonstrating my final project code with Python. My project is about trying to figure out the maximum capacity of a building with measurements X, Y, and Z. As you can see, with exactly 6,000 square feet of material, I wish to construct a building with depth X, width Y, height Z that can contain a volume V. My goal is to maximize the volume of the building so that we could predict the maximum occupancy or maximum load, using a similar example we used in Lab 10-2. I will be using scipy.optimize to find out the values of X, Y, and Z to meet the requirements. The measurements X, Y, Z, and the area of the building will be used as constraints. The area of the building should be exactly 6,000 square feet. I will use Solver to predict the occupant load of the building. Objective. Area should be 6,000 square feet. Depth times width times height equals volume maximized. That is a function I will be using in Jupyter Notebook. Depth equals 1/2 times the height. That is another function I will be using. Scipy.optimize. Another objective will be defining the functions, finding the values of X, Y, and Z. Use Solver to help solve the maximum capacity and dimensions. And another function I will be using will be occupant capacity equals area divided by the IBC occupant load factor. The IBC occupant load factor in this scenario will be 14. I'm using an example of that of a wedding hall. That is the IBC occupant load factor we will be using in this final project, since it is the biggest building I could find in the IBC chart. The math and science behind this is that it is a STEM-related project because of the mathematics involved. This is an optimization problem. The math behind this is that we are maximizing the volume to find total capacity, or in this case, maximum capacity since we're using the maximum volume. The question is, how many people can occupy the maximum space available inside the building? The science to this proposal is that it is like a science experiment. We need to test and run it to solve it. Here you're looking at the block diagram for my program. It has input and output. I'm defining the objective functions and constraint. I'm using optimize to optimize the volume of the building, solver to solve for the occupant capacity of the building, and the output will be the measurements for the X, Y, and Z components and also the maximum volume, and another output will be the actual occupant load capacity for the building. Here is the appendix of where I got all of my information. And let's move to the project design. Project design. My project will consist of Python language and Jupyter Notebook. The framework will mostly be from scipy.optimize and NumPy. I am debating on whether I will want to use Keras as a second option. The third-party modules I will be using will be scipy, Solver, and NumPy. My pseudocode will be import NumPy as NP from scipy.optimize import minimize, define the functions for volume and area, define and list the objective, define and list my constraints, make guess, prediction, create array to solve, use solver, and print the solution. Here is the block diagram again with the input, output, defining the objective functions and constraints, optimize, and solver. The list of functions include input, output, lines of codes, functions, decision making, and operations. Here is a sample input of my code. Let me see if I can make it bigger. I will be explaining the code later. That is how it should look. Sample output, it should give you the output of the total capacity as well as the volume maximized. And let's see. I will give you a project update. Hold on. For my project update, I was debating whether I wanted to incorporate Keras and TensorFlow for my project. I made a sketch on how it might look if I used Keras and TensorFlow. The depth, the width, and the height will be represented by X, Y, and Z respectively. Determining the weights of my neural network will be complicated because my project is a nonlinear deep neural network. That is why I omitted this design, and this is how I had planned at first of how I might incorporate that into Keras. We have the hidden layers here, the XYZ components for the width, depth, and height, the weights, the shape of the building will be the output, and I had another one, sigmoid activation here, and it would output the shape, but it was too complicated for me, so I omitted that design. And however, I did modify my project. I changed it so that the user can input any desired area, and the program will optimize the parameters as well as the volume. The output will be the occupant load, also the parameters of the building. First, at first I had said that the area was set to 6,000 square feet, but like I mentioned earlier, I wanted the user to interact with my program, so I included the area equals the integer input enter area number, so that the user could put any number that they liked, and it will output the maximum volume as well as the occupant load for their desired area number. Moreover, my program is very easy to use and simple in its design. It is not complicated to execute the result. However, I think I can improve its performance by maybe changing the code to something else, or maybe using a different package or library in the future so that it could perform much more quicker and easier, and it will do its best performance. My program does work, and I will show you and demonstrate how it runs. I'll do a quick walkthrough to my program, and this is how it looks. As you can see, I have the area, integer input, enter area number. That is where the user is going to put the desired area number that they want to solve for. I imported NumPy as NP. From sci-fi.optimized, import minimize. So I'm loading the packages and libraries from there. I'm defining my objectives, in this case the volume and the surface area. I'm also defining my constraints and functions, and then I created an array, and also I made a prediction of my estimated guess for the depth, width, and height. In this case I put ones because I want to solve for the actual measurement, so it's easier for me to put just ones than random numbers, so that it could predict it much quicker. And then I use the solver and optimize to solve for the volume optimized, and also to give me the calculated surface area as well as the occupant load. And here you can see at the bottom that I have the occupant is equal to the surface area divided by the IBC occupant load factor, and then it should print out the occupant load for the given building that you desire. So let's run it. Here it says enter area number. So let's try 6,000 square foot. Just like how I had in the beginning, I had mentioned that I wanted it to be exactly 6,000 square feet. Let's see what the occupant load and the maximum volume will be for that. It will take a couple of seconds for it to give the answers. And here we go. It gives me that the depth of the building will be 22.36 and all the other numbers. Gives me that the width is 29.8, height is 44.7, The volume is 29,814. The surface area is close to 6,000. It's not exactly, but if you round up, it will give you 6,000 square feet. And the occupant load for that building of the area of 6,000 square feet will be approximately 428 people. I didn't round up because, if you put one more person, it would exceed the limit capacity. Now let's try a different number. Not just that, let's do a different one. Let's run it again. Let's see 80 square feet. Let's see what will give you. It tells me that for an 80 square feet building, the maximum volume will be 45 cubic feet and the occupant load is 5 people. As you can see, I made an error because you cannot do small buildings in my code because of the occupant load factor that I'm using, which is 14. And 14 is the occupant load factor for a wedding reception hall, which is really big. So 80 square feet is not, I don't want to say the wrong answer, but it is not useful for this program because it is a small building and I'm dealing with larger buildings in this case. But let's do a different one. Let's try the size of the Galleria Mall. Let's do the area for that. Let's try 100,000. And let's see what the occupant load would be. Now mind you, I don't know the actual area number for the Galleria Mall, but I just made a prediction of 100,000. And it gives me that the occupant load for that will be 7,142.8. And the maximum volume will be it'll be 2 million, close to approximately 2 million will be the volume for that. And that is how my program works. And thank you for watching and have a nice day.